Hello, welcome to another episode of Let's Make It. This is episode number 49, and it's recorded on, what is it today? May 19th, 2014. And we normally record every Monday night, the best that we can. At least last month or so has been a little bit rough for getting Monday nights free, being on vacations and work schedules and things like that. But as usual, I am here with my co-host, Bob. How you doing, Bob?
I'm doing good. Vacation was fun.
Good. Where'd you go? Any more fun?
We went on a cruise and went to Cozumel, Grand Cayman, and Jamaica.
Nice.
So
was it cooler there than where you are?
I'm sorry, what?
Was it cooler there than where you are now?
Actually, it was a little cooler there than in Dallas. So.
Yeah, this time of year it's a little cooler there, because the water's still kind of cool. Hasn't warmed up yet.
Hasn't warmed up, but it was very nice, and the food was good, and of course it's vacation, so we spent too much money. But
yep,
that's what you're supposed to do.
That's part of vacation, right?
So it was good. I did think about electronics while I was on the cruise. I couldn't help myself.
So I have an episode coming up where we can track ships. I should have done that episode before you went, and you could have played with that while you're on the boat and watch other boats around you.
I almost took my GPS from a few episodes ago, but I figured I'd get my butt kicked by my family if I did that.
So was it just you and your wife that went, or did you take more with you?
It was my wife and me and my wife and a couple other family members. So
good.
So it was a good trip, but I did find myself looking at the electronic lighting and the digital signage and the computer network they had. The geek in me just couldn't keep control of it.
Yeah, so. No, I'm the same way when I go away, so I can't turn it off.
Can't turn it off completely. I did pretty good though. So
this week is a Bob episode. We're going to talk about some Raspberry Pi stuff again, right?
That's right. This is a project I've been working on. This is actually using some of the same components that we had a few weeks ago with the ultrasonic sensor. Only now I've got it connected to a Pi, and this is actually a project I'm working on where it will become a digital sign. And where it's going to be placed is in an entry area, and I'm going to use this sensor. And if the sensor senses a person walking into the area, it'll turn on a lamp. So this is a real world project for me, but since we were using it a couple episodes ago, I figured we might as well just go from keep the sequence in line and go from an Arduino to a Pi and demo this.
That sounds good to me.
So let me switch to the desktop. And here's the setup, and it's a Raspberry Pi connected to the ultrasonic sensor, and a two relay board, and the Pi is in back. It is connected to the network, so I can where did my VNC go? There it is. So I've actually had it running for a little while, but it's let me get I'll show you what it's doing. So the sensor right now is actually reading the base of the camera stand. So and the way I've got the code written is if anything comes within 10 centimeters of it, it turns on the light and keeps it on for 10 seconds. So I just did that for demonstration purposes. When I actually run this, I'm going to set it for anything that comes within 2 meters will turn on the lamp, and I'll leave the lamp on. I'm probably going to start off with 5 minutes, and then we'll see if I have to adjust it from there. But the code is this is the code that we're running, and I've got this little terminal window right here that's telling me what it's doing, and it's checking the distance every second. So you can see it's reading 25 and a half, roughly in that range. There's a little noise, there's a little imprecision there, but for what I'm looking for, it's perfectly good. That little imperfection right there isn't going to affect anything I do. And I'm going to stick my hand in front of it, and you can see that now it's reading a few 4 centimeters, 3, 4, 5. That's about right. So.
And what language did you write this in?
I'm sorry, say that again.
What language did you write this program in?
This is written in Python.
Okay.
I have debated over the last 2 weeks whether or not I'm going to leave this code in Python, or if I'm going to write it in C and have it run
Compiled.
as soon as the Pi comes on. But for the demo, I wrote it in Python, and I don't know. I may use this code. I haven't decided, but lots of people use Python to control various I/O, so I just went with that, just to be consistent with the code. So,
yeah, this library is now for just about every language, I think, on a Pi. So Python is probably the most popular, but I've seen shell scripting, I've seen C script, I've seen C code. So pretty much use it almost anything you want. In fact, from the shell script, you can just write to the control files directly.
That's right. You can. The advantage of using something like C is that you can get access to the access to the pins is pretty low level. So with C, you can get access to it a little easier. With Python, you actually have to run it. Let me kill this off. You can't run this as the normal user. You do have to run it as a root user. So that's why I'm using the sudo command here to give me access to root. So, but it runs. I ran it. I actually left this running while I was on vacation, and it came back. There's some error code in here. And when I got back and checked it, it was about 0.2% errors. So it's pretty 99.8% reliability on the measurements when you're doing a measurement every second. That's pretty good. That's more than adequate for what I'm doing here. So, but this is the code. So I'm importing a few libraries, and I create. This is kind of a style for me where if I'm going to use something globally like these pins, I use the global command and then set them as a number, and I have my variables as uppercase, which just tells me that that's kind of the way I've written code for 20 years. So that just tells me that it's a global variable. So I've set my pin numbers. And you can either set pins by their function or their physical location on the Pi. And I chose function because if I ever change versions of a Pi, then the code should work because it's based on function, not location. So, and here I've got this debug function turned to true, which basically puts the output to this terminal window. If that's false, then nothing pops up on the terminal, which will be the way I run it when this actually gets connected to the sign. So, and I wrote this code so I could use multiple sensors, although I'm not doing anything like that. But here I have a function where I read the sensor, and I'm going to return either an error code or the distance. So turn the warnings on. So we'll just go through the code line by line. I'm turning the warnings off, setting the mode to be functions rather than physical pins. I set up the trigger pin and turn it off. And of course, then I set up the echo pin because I've got to listen to it. And just like in the Arduino code, I turn on the trigger pin for 10 microseconds and then turn it right back off. And then I go into these listening loops. And essentially what this is doing is it's looking for when does the pin come on and when does it turn off. And if it waits for anything longer than 1 second, I assign an error code to it. And later on in the code, I can say, okay, well, if I got a 998 or a 999 back, obviously that's an error, and I'm not gonna pay attention. And I put this in here so just in case something happens to the sensor, I don't get locked in an infinite loop where it's waiting for some sort of return. And this actually reminds me of something important that I need to show real quick. There is a peculiarity of the Pi. The sensor runs off 5 volts, and the Pi will supply 5 volts. But the input pins back into the Pi are 3.3 volts. So if you don't do something, that ultrasonic sensor could burn up the Pi by sending a 5-volt signal back into it. And there's, when I was researching this, there's kind of 2 schools of thought. One is that you actually do a voltage reduction and send back a 3.3 volt signal. And the other philosophy, which is the one I went with just for pure simplicity, was to put a big resistor in place so you can't, you're still supplying 5 volts, but you're sending so little current back that you can't damage the Pi. So if you look very carefully, right there is a 10K resistor. So there's no way I'm going to burn up my Pi by accidentally sending too much current back to it. So sorry for that little detour. I should have mentioned that earlier and I forgot. So these loops are so back to these loops. So we're looking for either a second on or a second off, and then we time how long the echo pin was on, and then we do the calculation. Here I'm doing it in metric. So now these are, I don't want to get any emails from somebody saying, well, the speed of sound is not actually 34,000 centimeters per second. Okay, well, it's actually something a little higher than that. I know that, but I don't have to be perfect here. And of course, that's at sea level. And this isn't, I'm not at sea level. And so those values are kind of rounded, but it gives it, the number here is, it's valid for either inches or centimeters if somebody is interested in it. And then just because of what I'm interested in, I do a little math right here to round the number to 2 significant digits, do a IO cleanup, and then return the actual distance that was calculated. And then I have this loop right here, this while loop, that essentially will run until you hit a Control-C, or until I write some code to do something a little smarter. But it's keeping a count, and then it goes and asks this function for a sensor reading, and then it does a little, if it returns a 0, a 998, or 999, well, that's obviously an error, so we're going to ignore that. Then I've got a few lines of code in here that if I'm printing to a terminal window to give me some information. And then this is for, I'm setting up, this code right here is where I'm actually setting up the IO for the relay. And then here's where, then this code right here, if I'm reading the if the sensor reading is less than 10, which is the value, if it's less than 10 centimeters and it's greater than a 0, which is an error, then turn on the relay pin. And in this case, like many other relays, the high and the low are backwards from what you would logically think. So in this case, you set the pin low, which turns the relay on. And then later on, we'll set the pin high, which turns the relay back off. And then I have a debug statement. I grab, and this is for the output, again, is I calculate the time and give me the elapsed time that since the last time the light was actually turned on. So here you can see over here, we've gone 515 seconds since the last time I turned it on. And then when it's greater than 10 seconds since the light has been on, or the relay has been on, then I turn it back off, wait for a second, and continue the loop unless I've had a keyboard interrupt, which is just a Control C. And then if I do, then I quit out of the loop and I print this little summary of what the latest run of this code was. So I can hit Control C, and there I get my little summary of how it ran. And in the last 10 minutes, nearly 10 minutes, I've had no errors. So, and when I left it on while I was gone, 0.2%. So I would say that's pretty good.
Yeah, that's pretty impressive considering you're going for a week, right?
Yeah, I was gone. Yeah, I was gone for 8 days. So, but here it is sitting there running, and you can tell that it's reading 25 centimeters to the stand for the camera. And if I stick my hand in place, the light turns on, and you can see that in the camera. You can also see where the relay light came on, and so it's working. It's working just like it's supposed to. So
is your relay run? Can you drive it with 3 volts or 5 volts or both?
Both.
Okay. So it's going into transistor first, I take it.
No, it's actually this relay board. You don't. I'm not using a transistor. I'm running it right off the Pi.
Okay.
And it does have. I don't know what I'm going to do with it, but there is a second relay on there. Which, if I wanted to do something with another, I don't know. Maybe I'll plug in the monitor, and I'll turn off the monitor when nobody's in the room and turn it back on when somebody enters. So, but it's a nice little setup. So, and this is a real project for me. So
you said you were going to use it to display digital signage type stuff. Are you going to do the digital signage yourself, or are you looking to use like Touch or like the OSC thing that I was using?
I'm going to use the same. Yeah, I'm going to use what you were using before.
Okay.
That's going to work just fine for me, and then I'll have this relay code working in the background, and it should be a nice little setup. And this is going to be an entry area for a building for a nonprofit that I work with, and this is going to be a little project for them, that I'm doing for them. So.
So does the digital signage change when somebody walks in, or does it stay the same?
The digital signage won't change. It'll be updated based on whatever is the sign, but I'm thinking about connecting the monitor itself physically.
Right, so you save power.
Just to save electricity. Yeah, there's no reason to display anything on the sign when there's nobody in the room.
Right.
So,
right.
Of course, I'll have to find a monitor that'll turn itself on and off based on, if the power comes on, it'll turn itself on. So
right. Yeah. So an old style monitor, what you're trying to say.
Yeah, right. And of course, the last piece of this project that actually came in while I was on vacation was my HDMI to VGA adapter. So,
the other thing you might be able to look at is you can put a screen into power saving mode. I don't know what Raspbian has in it as far as options go, but you may be able to use that to turn off and on the monitor versus turning the power off and on.
Yeah, I may very well be able to. Now, the monitor that I'm planning on starting with is an old VGA monitor, so I may not be able, but I may be able to just blank the display.
Yeah, exactly.
Since clearly I'm going to know if the I've already written the code to know if somebody's in the room or not, because I've got the lamp on. So yeah, it shouldn't be that difficult to turn on and off the output to the monitor using some common code.
So in your case, what you just showed, the timer doesn't reset itself. So if you keep moving within that 5 centimeters, it doesn't stay on, right? It goes off and back on again.
It will stay on 10 seconds past the last reading.
Okay.
So
okay.
If it keeps sensing that somebody's in the room, it will keep that lamp on. Or yeah.
Okay.
Yeah. That would be kind of silly if I
turn it off, back on. Turn it off and back on.
that would
work that relay. Work that relay.
Smart. So, but yeah, the way the code is written, and obviously 10 centimeters in 10 seconds isn't really useful for the real world, but it works just fine for the demo. And
right
now, I mean, you can tell when the lamp comes on. The lamp is actually sitting right above me, so I think I look a little better when the lamp is on.
So just keep waving your hand.
Yeah, I keep waving my hand. Here, I'll just stick something in front of it, and then the lamp will stay on. And of course, more than one person has noted that I have a face for radio, so maybe I should turn the lamp back off.
That's okay.
But but it's nice to, this was a nice little back-to-back project doing the same thing on 2 different platforms with 2 different programming languages.
Right. Yeah. And the Pi is a little different it's not really designed the same way that the Arduino is. Well, the open pins, they use a lot of those pins for other things. So you don't have as many of them.
Yeah. You have very few pins compared to useful pins compared to an Arduino.
The other thing is there's issues with timers, so you gotta be careful. Like the I2C stuff doesn't work always so well with a Raspberry Pi because the timers in the chip is not as accurate as what's in the Arduino.
I haven't done anything with that yet, so who knows? I may very well try something.
Yeah, I've experimented with some of that stuff, and it doesn't. That basically it works sometimes, but not reliably. So I've never used it for anything that needed to be reliable. Which was kind of why the Udo board was interesting, because it has basically a 4-core, the same CPU that's in the Raspberry Pi, plus it has the CPU for the Arduino. So you can have the Amtel and for the Arduino do a lot of the hard work as far as timing goes, and use the Elwin for runs Unix or whatever, and it does all the. So and they communicate back and forth to each other via serial. So it's real easy to program. It's kind of like taking 4 Raspberry Pis and Do and putting them together. So all on one board. It's kind of neat. Although it's a little confusing till you get the hang of it. But it's neat that you have 2 separate CPU operating systems and everything running there.
Yeah, that is a little confusing. And at least with the Pi. And the funny thing is, I'm not using anywhere close to the Pi's capabilities.
Right, and you're even running X Windows on there too.
Right. Yeah, and that's right. Yeah, and that's actually what most of the if you watch this carefully, most of the CPU usage on this thing is actually for the X window.
Yeah, I generally turn off X Windows unless I really need it for something.
Probably I will have it off when this thing is in production.
Well, you're going to need it for the same software. The Screenly software uses X Windows.
Oh, it does. Okay.
It uses like a web browser inside of the.
Well, it's not having any trouble. I'm running probably about, looks like it's averaging between 15 and 20% CPU usage right now.
Yeah, I mean, it's pretty amazing what it can do. I've been playing with ADSB, and I put it on to a Pi, and it's just not using anything on the Pi. It's crazy how powerful they are. So.
Yeah, it is. It is powerful. And what's sad is my very first PC. This thing is far more powerful than that.
Oh yeah, mine too.
Yeah.
My first PC couldn't do any kind of multitasking. It just, it was strictly one thread, and that's it.
That's right. Well, it kind of dates me, but I actually used Windows 2.
Yeah.
So that's really sad.
I played with Windows 2. That was back when there was the IBM version of OS2, right?
Yeah, that's right. Yeah, and then I had a machine that had DOS. When I bought it, it came with DOS 6 and Windows 3, and they gave you the 5-inch floppies to upgrade to 3.1. And I think it was 3 or 4 floppies, if I remember right.
Yeah.
So, just amazing. So, but hey, a few years from now, we'll be reminiscing like this about the hardware we have now. So
the kids now, you give them a cassette tape and what's this thing?
Yeah, that's right.
I remember my TI 9940. That's how I loaded in programs, was using a cassette tape player.
Yeah.
To save and play them back. So yeah.
Well, I had and I had an old Commodore 64.
Yeah.
And the floppy drive, I had programs on 5-inch floppies for that. And, that floppy drive that thing was huge, and it weighed a ton.
Yeah.
So
it's amazing how technology advances.
Sure is fun.
Yeah. So, I have bees in my backyard, and I have a friend who sent me this link probably 4 weeks ago now, of people wanting to do sensors in beehives. So I'm starting to investigate that.
Okay.
They mainly want temperature and humidity, which is pretty easy with a DHT11. Just stick one of those in there. Put one in each body, probably in the center of the hive in each body. But they're trying to do some audio type stuff too. They say that based on the frequency of the audio, you can kind of tell what the bees are doing, or if they're going to swarm. They have these different sounds. So I'm looking into how to do audio, either on a Raspberry Pi or an Arduino or something, and because the Raspberry Pi doesn't have audio in, only has audio out on it.
True.
So I'm trying to figure out the best way all I need to do is measure frequencies. What frequencies I don't want to record the sound as much. I want to record what the wave looks like. And every so often just take a picture of it.
That sounds like an interesting project.
Yeah. So I got the extra frames for the beehive, so I'm going to start playing with that here soon.
Well, this week will be get the digital signage part, and I'm still trying to figure out a little box that I'm going to mount the Pi and mount all this hardware in and have it look presentable for an entry area. So
yeah, so is it you can put like in a kiosk, or is it just like on a monitor sitting on a table somewhere?
It's going to be a monitor sitting on basically a wide credenza in a open area. The actual where the sensor is actually going to be pointing, there's probably 25 or 30 feet worth of distance, but it's only when somebody actually walks into the entry area itself, which is 6 or 7 feet away from where this is going to be sitting.
Okay.
So if somebody's walking in the hallway,
you don't want it to come on then.
Then I don't want it coming on. But if they actually walk into the room, then I want the lamp and the monitor to turn on.
Right.
So, but so this week will be mounting it and making some sort of display that is nice.
Right. I'm curious also to know if the error rate goes up when you got something that's farther away.
That will be interesting, but I'm going to keep this logging code in there, at least for the time being, so I can keep track of that and see how many errors I'm really getting.
Yeah.
And then I'll also play with the timing. Do I need to leave the lamp on for 5 minutes? Can I turn it off after 2? We'll just have to play with it and see what works the best.
Right. Right. Very cool.
So, a nice little real world project. So,
yeah, it sounds good. All right. Well, I don't really have anything else for this week. I'm kind of out of things right now for the next couple weeks, but I guess we need to talk about for next week as well. But for this week, I think we're pretty much done, right?
Yeah, I think we're good for this week.
All right, then we'll go ahead and sign off and see everybody next week.
All right.
All right. See ya.
Good evening.
For show notes for this show, contacts, and more, go to the TechZen.tv website where you can get show notes for all of our shows. We love to hear from our viewers and listeners. We have an email, a Twitter, and a phone number where you can contact us for each show. For details, visit the TechZen.tv website and get the show details. You can also make a video and upload it somewhere like YouTube or Vimeo and then just send us a link. You never know, you may see your video in a future show. You can get all of our shows delivered automatically to your favorite device by going to your favorite podcast website like iTunes and subscribing. Each of our shows also has a YouTube channel you can subscribe to get regular updates. Our shows are also available on most internet radio networks like Stitcher and TuneIn Radio. You can also watch and listen to our shows on Xbox, TiVo, and Roku. You can even find us on your Zune.